Hello, everyone.
Hi, Mike. Hi, everybody.
Hi.
I'm very pleased to say that my meeting, which had been clashing with this meeting for months, has moved. So I now should be able to make this meeting more often, which is very good news.
Yeah, that would be great.
So apologies if I take a bit of time to catch up with everything. I haven't managed to watch all of the videos or read all of the minutes, so I'll do what I can.
Yeah, sure, no problem. I think we tend to forget things, so kind of have to repeat a little bit to give some context. So things are like that. Uh, yeah, but no problem.
Okay.
Feel free to ask if you need to.
Hey, everybody. I hope everybody's doing well. Happy New Year.
Happy New Year.
Happy New Year. Hi, Greg. Hi, Greg.
Happy New
I
Year.
don't see Keith
Hey,
here. So if Keith doesn't show in the next minute, I will take over the chair the chair for the hour. I think looking at the attestation meeting notes, it looks like there's three different topics on the agenda. It looks like some continuation of some discussion I didn't attend in mid-December with Osama, another one from Osama, scoping of agentic AI project, and Stephen SPDM standard measurement transcripts. Um, do we have a sense on what makes the most sense from an ordering perspective? I think Stephen indicated uh, his content was probably pretty brief. So that gets me to think perhaps put that one in at the front. Osama, uh, conversations tend to a lot of times get going once you get going. So there's just one thought in my mind. What do folks think about that?
Yeah, sure. That's perfectly fine for me.
All right, I still don't see Keith here, so I think it makes sense to get going. So do we
Greg.
welcome back?
Keith, sorry to interrupt. So I think Keith has some other things, so he may not be able to continue to serve the as president for this quorum. I can start taking over that part, but I would like to shadow a few sessions before starting.
All right, so thank you for that information, and um, yeah, I appreciate those thoughts, and let's um, let's formulate a plan for what to do there. And I don't want to speak specifically without kind of talking with the other co-chairs before we kind of um, figure out next steps, if that makes sense.
Makes sense.
But yeah, I mean, what you're saying seems reasonable to me, but I think we should kind of speak as a set of co-chairs. So, okay, so before we jump into the three topics, does anybody have any announcements they want to make up front about anything? I'm looking at you, Mike. You tend to have something to say usually.
Which mic? Do you mean me?
Yeah, I'm sorry. Yeah, Mike
Oh,
Purcell.
that's all right. I'm not sure if there's other mics. Well, as I said, I've not managed to make this very often recently, but the clash I had with it has moved, and I'm hoping to be able to make it more frequently. So nothing particular. If anything comes up as we go along, I'll try and get an edge and say something. But let's just get on with it, I think, at this point.
Okay, great. So then let's just so Sama, thank you for being gracious with the ordering. Stephen, I see you here. Would you like to uh, take over and present on SPDM standard measurement transcripts?
Yep.
And thank you very much for agreeing to present. I looked over this website this morning and looks or the link in the in the lists archive, and it was definitely interesting.
Yeah, so the motivation for this is that the SPDM requester is the one that gets to form and orchestrate the get measurements command in order to get measurements or evidence from the SPDM responder. And the SPDM specification gives it a bunch of knobs in order to do this. So like one of the knobs is, either getting all the measurements from the responder or getting individual measurement indices from the responder and specifying certificate chain slots. And then, whether or not it's going to have a signature, whether or not the measurements are going to be a raw bit stream or if they're hashed. And then this one's kind of a new one. This one allows the responder to report staged measurements. So if you do like a firmware update, but the update hasn't taken place yet, then the requester can ask for the measurement of that firmware update that will happen in the future, and the responder can specify it. So yeah, there's a few knobs that the requester has. And it's possible that an ignorant requester might do things such that when it hands the evidence back to the verifier, that the verifier doesn't like it. So one of the things it could do is it could do like, give me measurement into C1, give me measurement into C2, give me measurement into C1, kind of like a ping pong back and forth, and it hands it off to a verifier. The verifier says, I don't like the way you formed that. And there's nothing in the SPDM spec itself that kind of constrains that. So what we did in the SPDM working group, this is in our public libspdm repository. So libspdm is the reference implementation of SPDM. And it's co-project, or the co-chairs are from me from NVIDIA and Jay Wynn from Intel. So we kind of constrain what can happen here, and we give it a name. So we've got this DMTF standard measurement transcript document. We give names to two measurement transcripts, and we specify here, or we describe how those things look. And the purpose of this document is for a verifier, mainly a verifier, to say, I support, the single request measurement transcript definition, or I support the multiple request measurement transcript definition, and possibly just make that exclusive. So the verifier could say, I only support the single request measurement transcript definition. And for example, the NVIDIA remote attestation service for confidential compute, this is what it expects the measurements to look like, this single request. So any questions so far?
I've got one. Forgive me for being terribly naive. I work on MAA to date. We're not actually verifying any SPDM evidence. None of the scenarios have intersected that. So this is all new space for me. What are verifiers doing currently before this proposal came along?
Well, I can speak for NVIDIA. So NVIDIA, it's like hard coded into the requester and the verifier. So the NVIDIA requester that we have now that runs in the Linux kernel, this is the only thing that it does. Like there's no room, and then the verifier expects this. So and because NVIDIA owns the whole stack, we can sort of do that and hard code it in.
Okay.
There may be a time where you have more generic verifiers that could support a diversity of SPDM measurement things. I would imagine, like, if I'm a verifier writer, like this is the one that I would expect, because you're getting all the measurement indices at the same time, and they're all signed, and you don't have to worry about multiple messages. You just have the single You just have the single get measurements from the requester and the measurement response from the responder, and within that, that's all of your measurements all at the same time. So, yeah.
Stephen,
This,
if the responses are composed, if the response is composed of multiple individual signed responses, then there is that potential issue that they do not reflect one given state in time. And so
Yep.
I think the single request is actually very well justified from a security standpoint.
Yeah. So this ensures atomicity. You have the single request, the single response. In theory, all of the measurement indices should be consistent with one another. When you go into the multiple request messages, yeah, you have the issue that measurements might change, or once you bundle them all up, they're inconsistent between one another. So yeah, having worked in SPDM for a while, I would imagine pretty much every verifier would at least support this, if not only support this.
So this may be a naive question as well, but if I understand it correctly, when the SPDM session is set up, the driver does verify the NVIDIA signature and then create the measurements and it generates the transcript. So does transcript also include the certificate chain to verify the NV signature again by the verifier, or it just says the driver already verified it?
No, so this is just the measurements themselves. So the certificate chain is sent, along with the measurements, but it's not part of what we're defining here.
Okay, thanks.
So in EAT, so once EATs come along, there is a way where you can embed the certificate chain in the unprotected portion of the EAT, and then you have a very standalone object that has both the certificate chain and all the claims and measurements and whatnot. And then it's large probably, but it's definitely a good standalone object for evidence in the certificate chain. But this one's just concerned with the measurements and the evidence.
Yep, makes sense. Thanks.
Yeah, so I'll post this in the chat, and you folks can read it. It's intended for these things operating in production mode or in a production environment. So like the raw bit stream. So one of the things you might do is, for production environment, you might want, or you do want, the hashes of like the firmware. But if you're in like a debug environment or you're doing forensics, maybe you want the raw bit stream of like the firmware or the hashes or whatnot, assuming the raw bit stream of the firmware or like registers or whatnot. So assuming the responder supports it, that's an option. But for this document, we're assuming production. So we don't care about the raw values, and we don't care about like future values. We only care about the current state. So yeah, I'll post this in the chat.
Cool, thanks, Stephen. Forgive me if I missed it. I think you did mention it. Now, for the given Dual's description of some of the security properties, that the components for the multiple message may come at different times, what was the kind of typical example of why the multiple one would be used?
So that was brought in from Intel.
Okay.
They were concerned about message chunking. So by getting the individual indices, you are transmitting smaller messages because you're only getting one index at a time. And so you can do these multiple small messages, and then the requester can bundle them up into a much larger transcript and then send that off to the verifier. So that's for kind of like the older SPDM versions. The newer SPDM versions support message chunking. And so even if the measurement
Oh, I see.
response is large, SPDM at the SPDM layer allows it to be chunked and then transmitted. So
I think part of what I'm hearing is that this probably won't get much use especially as time marches on, as the newer SPDM is implemented more and more.
Yep.
Okay, thank you. Okay, next topic goes to Usama. And Usama, I'm going to let you pick the ordering, but based on what I think I've seen of the history, it sounds like there's a conversation to complete about a tested TLS. And there's this other topic of scoping of an agentic AI project, which hasn't been discussed yet at all. So I'll let you pick what order you want to do.
Sure. I think the two are kind of related. I posted one analysis in the email to the list. And so I've kind of merged both. So if it's fine, I will start with some background, giving some analysis that we have already done. And probably we can see how to scope that and how to take it forward in the SIG, or if there is enough interest, like, or where does the interest lie in the SIG for this kind of work. That would be kind of the interesting part for me. So I'm going to share the screen. Okay. I hope you see the slides now, and should, if you can confirm, then I start. Do you see the slides?
Yes, we do.
Yeah, I can see the slides.
Okay, thank you very much. Right. Yeah, as I mentioned on the list, so I with Vyacheslav and Jan-Marie, we have done some analysis, and several people here helped us in this analysis, particularly the two at the SIG have also helped in several of the questions, clarifying the things and so on. So thanks to those. Also, I'm waiting for some feedback on the list. I'm going to kind of start with the approach, and I have only a few slides where I will, some of them are recapping what we discussed in the last one. So this is something new. I've tried to put them into blocks, what this all of the stuff is and what changes in the approach. I'm going to start from the left side top. We have, and which is most related to this SIG, which is that we have two different types of attesters, layered and composite. Of course, that can also be hybrid and other ones. So we started with these two. For example, in layered, we consider Intel TTX. In composite, we consider ARM CCK. And that forms the foundation for the hardware or the system that we have. And then from there, we build the system model of what we are going to analyze, what are the hardware primitives and all that. So this part is forming system model. And this is the part related to agentic AI. Mostly, I kind of introduced it when I pitched it last time. And the idea was that this agentic AI would have a number of AI agents, and each AI agent kind of doing its own job, and it can delegate it to some other agents. So that's the kind of complexity it has. And it can change at the runtime. That's another issue that you have to track not only what software was running at the beginning or at the boot time, but also what was happening at the runtime. So that's the kind of additional complexity in these kind of systems.
Can I ask a question or make a point?
Sure.
Which is that one of the difficulties here, of course, is that when we say its behavior can change, that can mean anything from new binaries to just a new policy file or just some data. So how it's possible to tell or for the agent to say that it has changed is fairly complex, I think.
Right. So that's one of the challenges that needs to be
Okay.
solved or somehow fixed. So we started very small. That is to say, we don't take any policies. We, for now, care about, let's say, only the binaries and the data. And that's the kind of
So the what
conceptual.
piece? Sorry,
So the data and the binaries. So we don't take that the policies are changing. Let's say policies are
I didn't
currently
catch the second word. Boundaries, bindings,
binaries.
binaries. Sorry. Okay. Yeah.
Yeah.
Fine. I had a D in there, which wasn't okay. And the binaries. Okay. Fine.
Sorry. Yeah.
What do you mean by binary? That's the next. Is it a? Sorry. Right. Okay. Fine. Yeah.
Okay, so that would mean the piece of code for which we have that measurement. And
Fine. Yeah.
of
That's a
course,
good start.
yeah, and of course, at a formal perspective, we are abstracting a lot of things. And that's one of the things which I call as scoping, like which direction is interesting for the SIG, what areas would SIG be interested in, and what should we be doing mutually. That's the kind of questions that I currently have. Any other questions or thoughts so far?
I've got some stuff, but I'll leave it to later on, I think, probably.
Sure. Okay, for others, feel free to interrupt. Uh, I would like more of a discussion here, so because it's more of a research topic rather than development work. So from agentic AI system, we have some security goals that we need to satisfy for attestation for TLS and the combination that is the attested TLS. So we are currently focusing on that part, which is most relevant to this SIG. And that's one way of representing the attested TLS would be the correlation properties for which we have the formalism we have developed for it. And we define the binding levels that we had a long discussion last time and also some discussion on that follow-up. So I have one slide just to conclude that part. I hope we kind of concluded it in the list as well. So just to summarize that. And of course, we need some threat model whenever we talk about security. So threat model also defines some parts of the system model, which part is relevant, which is not, and which is our target, what the attacker can do, what it cannot do, as well as it has a role to play within the correlation properties. And then based on that, I will go now to the top right part, which is the system model, which was defining what hardware primitives we have and so on. Together with the threat model, we will have that attested TLS part, like what protocol is it running in order for communication with another AI agent or with the orchestrator. So that's the kind of communication part in this green area that we have the formal model for. And what it takes as inputs will be what is the binding mechanism that is used to bind the remote attestation evidence with the TLS connection. And then we consider here we consider four binding mechanisms, which I will describe, and here we consider four practical implementations. One is the adopted SIG project. There are three other implementations which I will describe then, and also edgeless contrast, which was already presented at the SIG once, and two others. Okay, we will come to that. Anyway, the idea is that we take practical implementations, we take different possible binding mechanisms, how to combine the two, and then we do exhaustive search on this formal model, which is built from these protocols for communication under this system model. And does it satisfy these properties or not that we have here, the correlation properties? And that's the formal analysis part, taking both inputs, trying to find out whether it satisfies or not. And what we find is the relay attack that I will describe you two variants of what we have currently. And of course, it's an ongoing research, not yet like finalized, of course. and we propose some proposed mitigations to kind of mitigate that, but not fully fix. We don't have a fix yet. And the focus of our tested TLS protocol in this specific work was intra-handshake protocols, because that was the priority for current analysis, as the area director required us to explore them first. So that's why we have exhaustively checked the binding mechanisms within that protocol, within intra-handshake. So with these proposed mitigations, we go back, try these out, and then see whether they fix the attacks or not. And that's the kind of then the loop uh, that we have. So this is the overall kind of the picture of the whole approach. And then I will describe you then bits and pieces of all of that in the remaining slides. Is the overall idea clear enough?
Yeah, maybe now's a good time to give my thoughts. So
Sure.
I, this is important stuff, and I want to make sure it doesn't happen in a vacuum. So one thing I'm
Mm-hmm.
trying to do in kind of my executive director role is uh, make sure that we can make contact with practitioners who are doing the work at other levels. So a few weeks ago, the confidential computing, sorry, the LF announced, as I know you're aware, this new
Yeah.
AAIF, Agentic AI Foundation, and I'm trying to make contact with them. But before I do that, I'm writing a very basic blog post explaining why this is a problem. Why isolation is required for agentic AI, basically, so that we can have something to point people to get them interested. And I can then say, look, we're actually doing more deeper work in this SIG, for instance. And I also want to get the folks in that world to be engaged with and taking and actually helping along things like threat modeling, so that the requirements are reflected in what they think is how the world is going to work. So I think this is going to be valuable anyway, but I think we need to be aware that things might move in different directions, and that what we think is going to be sensible may not end up being what the practitioners end up uh, espousing. Does that make sense?
Yeah, sure. That makes perfect sense. And we would be actually very happy if you can connect us to them.
It's
Like we
it's
would
it's it's
like to.
very high on my list of things to do. I've been writing that article for the last 2 or 3 days so that we have something to go to them with. And so
Okay.
that is absolutely high on my list of things to do. And once we do
Cool.
have any sort of bites of interest, I'll try and work out how best to connect people through. Because I think
Okay.
having practitioners, or people who think they're practitioners anyway, understanding that this is an issue and that we actually have some ways to think about it is the right way to do this, to show that we have expertise that they can leverage rather than trying to force them down a particular way of thinking, which is how they might think we were doing it.
Right. Absolutely. I think it's important to have contact with the practitioners. At the same time, I think it's too technical for the practitioners to actually understand how all of this complex technology is working.
Yeah, so
So
we,
it's
we need to find people
yeah.
within those companies who are security people who we can bring along and make sure that we're doing the right stuff and bridge the gap. So I don't
Mhm.
expect them to get involved necessarily at this level, but there'll be people at Google and Nvidia and all of these companies in Inara and Microsoft who are doing some of this stuff. So we need to try and make the connections internally within those companies as well, who are represented right here now, right now.
Yeah, sure. Yeah, definitely. I mean, if someone can provide some further insights, that was the whole purpose of sending it on the list, that whoever has
Yeah.
any contact or any insights, we can get the discussion going. And I do have also some questions, discussion within this presentation as well. So yeah, if you
Yeah,
find
so I
something,
would encourage people who are here or who listening to this later on YouTube to work out who in their companies is involved in specifically the AAIF, which is the Linux Foundation um, new foundation. I will put a link to that AIF in the notes from the minutes for this meeting, so people can use that as a starting point. There we go. Thank you.
Cool, thanks. Any other thoughts on this before I proceed to next? Okay, if not, then let's proceed.
Sorry,
So,
can
yeah,
I,
sure.
just
Yeah.
just with my mic. Not with that mic, just with my mic. So maybe I missed it, but can you like say a little bit more about this agentic AI thing? Because I don't even see any attachment to attestation and why this is even interesting in the scope of that. Like it's a
Sure.
relevant
So
topic and
they,
timely, but
the
why? What are you
yeah.
testing here? There, that
The
doesn't make sense.
the AAIF is supposed to be pushing open source and standards for AI for agentic agents, right? And one of the first thing I think that we need to make clear to them from the point of security is that they need isolation, that agentic agents need isolation, and that confidential computing is a way of doing that. Right? And so actually confidential computing is something they should always be considering when they're looking at running any agents pretty much anywhere. Once we have that conversation, there's the okay, well, what are you trying to achieve and what are you trying to protect and what are you trying to isolate and what types of assurances you're expecting? So that's obviously a next level down. And then we get kind of further and further down towards this. There's quite a lot of space to be bridged between this sort of work and convincing people they need to think about isolation in the first place and that it's important and that they can't trust the infrastructure. And that is the kind of work that I'm trying to start off. Make sense?
So with everything you said, I'm fully with you, right? That all makes sense. I'm just trying to understand on this slide kind of the how formal modeling plus attestation fits together with AI. I'm all about AI and CC, right? The tested workloads, like yada yada. I'm very happy that we have these pushes. I think they're all very, very necessary. But to me, the formal analysis ends at the level of protocols, at the level of testing the system you're running, whatever you're doing. You may even go as far as modeling like some properties or threat models or whatever types. But then to me, AI is a workload running on top, which is attested. And so you can, of course, like use other workloads as well. But I just want to understand if there's like agentic AI on
And
the
you
slide.
kind of asking,
Usama,
is there anything special about agentic AI as opposed to
I'm
other
more
workloads?
asking
Is that
to
the question?
Usama, yeah, I'm more asking to Usama, is agentic AI here a buzzword on the slide, or is there more behind it that you wanted to have on the formal analysis?
So from my perspective, if you're asking more from formal perspective, that's the thing here which is different from what SIG has already done from a technical perspective, is that agentic AI contains a number of agents. So of course, there is a lot of terminology miscap, like people use it in very, very different terms. The way we use agentic AI is that it's a combination of AI agents. So we distinguish between, as I presented in one of the last meetings, that was, of course, some time ago. So AI agent versus agentic AI, the fundamental difference is that the agentic AI is a combination of various agents. And here the property, which is the relay attack, is very important, that one of the agent does not forward it to some other agent which is untrusted. From a formal perspective, what the SIG has currently done, none of that covers this kind of thing, that it's like, and this binding mechanisms, we haven't currently explored that specifically. If you talk about, let's say, a technical contribution from what SIG currently has, we haven't really explored those at all. We have just three SIG projects, which were Intel's RATLS, then a test ATLS proof of concept, then one was on key broker service. So we had very, very specific projects, and each one of them had like formal analysis together with those, which we did and completed. So we never explored what are all the possibilities and what we can do. Or I see a lot of problems, which I will describe you in the remaining slides as well. Like people are misusing all the all the things that, I mean, they're not really misusing is probably not the right word. I mean, they are really abusing the TLS protocols. And for example, SNI field is supposed to be for some other purpose. They are using it for conveying the attestation norms. So, and then there was a claim on CCC Slack actually that, hey, we are doing the best thing, Coco's AI, that we are the best in the whole community and look at our artifacts and this and that and so on. But they are really doing, if you look at the technical parts, they are really doing like, they are abusing the TLS protocol primitives, which is to say that SNI is supposed for a server name indication, and they really use it for conveyance of nonce, which is not it is meant for. And that was my purpose, that we need to give some guidance to the implementers how to do things right. And that's the real contribution of this work, which has not been explored in the SIG. So other than from research perspective, it has a very practical part, which is 4 practical implementations, all possible bindings, and giving them concrete kind of, let's say, guidance on what exactly they can use in order to achieve the guarantees, and not just abuse the fields which are not meant for some different purpose. So that's from that perspective, like this is one completely new thing. This formalization we haven't done before. This is completely correlation properties are completely new. Binding levels we discussed last meeting. So this is from a technical perspective, this is completely new. And the resulting relay attack for this agentic AI, that's completely new, which was not in any of the SIG projects. What's kind of what we already had, or what we are reusing, so to say, is this, which we had this project on ARM CCK and TDX. So that's the only part which we are reusing. Of course, from a tested TLS perspective, I am partly reusing some of the code that I developed. I mean, it's not from scratch, all of the things that I will do for this, but there are quite a lot of new things as I have described, like these two. This one, the relay attacks found, like the new properties and multiple AI agents. We have previously looked into just one workload, which is uh, in isolation, let's say, without any connection to anything in the world. So does that clarify the whole scope or different things which are technically relevant other than the buzzword of agentic AI?
No, yeah, I wasn't even asking much about the whole project. I was really just asking if agentic AI is just like a example here, or if you really intend to build it around that. But it sounds more like it's just an example in your case for a workload that you want to run, right? Because it's just a workload. That's what I'm trying to understand. Like in
If
my
you
like how I read your slide is instead of agentic AI security goals, I just like mentally override it with workloads. That's how I run what I read.
um
But you seem to be focused on the agentic AI. That's why I'm just curious on why
yeah,
you.
so
I'm sorry for jumping in, but it just relates to the question I have, which is the part I caught that really stuck with me was you showed something else briefly, Osama, where it was about the relay, the relay properties, and you want to make sure that, one, it's about a collection of agents. You want to make sure that the agents do the right things relative to the other agents. And when I think about it, to me, that sounds there are other composite confidential compute workloads, scenarios, systems, however you want to think about it, that I suspect have similar requirements, right? If you have, for example, an attested a VM that's working with an attested GPU in the same, on this, hopefully on the same machine, right? So do you, I suspect, maybe I'm wrong, but do you have kind of similar high level problems? Like you have these two attested entities and they're trying to collaborate on a single problem, and you want to make sure that all the right things happen between them in terms of, all the security threats, man in the middle, et cetera, et cetera. Um, is that how you're thinking about it, or is it? is the class of problems that this pertains to, all classes of problems where there's a composition of attested components? Or is it strictly just AI agents attested components? Or doesn't even have to be, a collection of components, it could just be one. I think it's a collection, and I'm hoping that it could be more than just AI agents.
Um, I try to distinguish a little bit between agentic AI and AI agents, uh, in a sense that agentic AI is multiple of those AI agents, and you can very much think of it as multiple workloads because the level of abstraction that at least currently we are not specifically tied to saying that we are using some very, very specific, let's say, something very specific about agentic AI other than just that there are multiple workloads which need to kind of collaboratively work together. And what I'm saying is that the SIG currently doesn't have anything for that. It's only the formalization that we have done before in our projects is very limited to just one piece of workload. So if you will, you can simply just replace this one by a composition of workloads was probably the term that you used, and maybe
Mhm.
something like collaborative kind of I mean, they are both also communicating. It's not only one way, so they are two-way communicating with each other. That's what we understand it so far. And of course, for formalism, we lift it up to a very abstract level then, and then it doesn't really matter whether it's agentic AI. The thing that we need to discuss specifically is exactly this question.
So
And yeah.
let me try one other question. So what if a single
Mhm.
workload is composed of a bunch of attested components? Does the work here also apply to those attested components working on what in this discussion was called, let's say, a single workload? It's just like it's one agent in AI, or it's one workload, doing whatever the pay system for a company or something. But it's running on, it's running on a system of compute that is, a collection of a collection of attested entities. Does the
I
problems
would
you're looking at here different or the same as those two?
Um, it's a bit of a tricky question. I mean, it goes to the definition of what definition of workload I have versus component. And to give you one reference point for that, like Whimsy working group of the IETF had a lot of debates about what workload means to them. And then what attestation means to them has recently been the discussion. So these kind of discussions never come to an end. Like you can never define workload or a
Yeah.
component to a satisfaction of everyone in this call or everyone in the world, let's say. These are difficult conversation. I would say at whatever level of abstraction you want to abstract them, for me it's important that whatever you call it, it's workload or component or whatever XYZ, they are communicating with each other. They can send over or relay some things over to something else, and we want to ensure that something else is not malicious. It's not leaking out my private data to what I did not explicitly allow to. That's whatever terminology you want to put it, that doesn't matter. That's the property I'm looking for in
Well,
this specific work.
then
Does
I
that?
think when I listen to it, it sounds like it could apply to very low level components. It's like any attestable component that's collaborating with any other attestable component, and
Mhm.
how they interact, trust each other, relay messages or whatever, where they have to communicate with each other, perhaps bidirectionally or perhaps unidirectionally.
Sure. Yeah.
That's matches what you're thinking about here. So then the labeling it agentic AI is like at least four steps in my head to get to like some of these things where I think now that you described it, some of the stuff you're studying could be applied. So I don't know what's the it gets it's a lot easier to I think it's a lot easier to be clear with specific examples like collaborating agents and agentic AI versus try to describe how, it's just, this could apply to anything and it's just, any attestable entity. And so I do get that it's simpler to kind of explain, but if it really is applicable to all these different things,
So, Greg,
one.
I think at the level we're discussing at the moment, it is that might change once if we do go down this road and look at the threat model. It may be that the threat model differs for agentic AI versus some of the other use cases that I agree in the current description are not excluded.
Yeah. I suspect, I may be wrong, but I suspect that there's a lot of stuff that's in common. Then there's nuances for particular circumstances. Oh, this is hardware on a motherboard, or oh, this is.
I think I can think of a few use cases where agentic AI may be a bit different. I'm not sure I'm ready to stand behind them at the moment, but I'm not ready to rule them out at the moment. I agree, and what's more, I think that the general case is worth looking at anyway. Obviously, it's a larger scope, and that's one of the questions. If the scope is different, is it worth trying to work out what the difference in scope is, and therefore, how we would focus on that scope or not? So I kind of found myself halfway between the views that I think the two of you are espousing.
I think that I think Osama should study whatever he ends up being motivated to study, and I'm certainly appreciate that he solicits feedback from folks. I think the most important thing I think I would want to make sure is kind of on the table. If the work that's being done here, once it becomes concrete, is that it gets credit for everything that it should get credit for. So maybe if it's labeled AI agents and sub agents, but it could be applicable to any kind of composite attested environment that meets these criteria. If at least there's kind of like one slide somewhere or one paragraph in the doc that just kind of explains, hey, if you're in a composite attested environment that has these characteristics, then the kind of work that we're doing here
and I agree with that. I think one of the reasons, with my most venal of hats on, is the word funding. It's going to be easier to get funding if this is specifically focused on agentic AI than if it's more general. I suspect. I may be wrong, but I suspect that. And we kind of live in a world where that is important to consider. But I agree. We really mustn't be too specific if there are more general cases. And I think the jury is out on that. We've not heard I've not heard anyway, something which leads me to say this is only an agentic AI use case or set of use cases at this point.
Okay, sure. So I suggest that we proceed and try to go through the stuff quickly and then take it on lists because I'm not attached to agentic AI.
That sounds
As I
good.
said, we can kind of put it in some different words and then have agentic AI as a specific one. I put it specifically because that's what we studied typically, or at least for me, as a researcher, I don't put other stuff or make it more generic when it is not. So this is the system that we studied, and that's the result of our study. Specifically, we used Meta AI and all that. That was very specific. So I don't want to generalize my results to be applicable to all of the systems in the world. So that was the reason for this. For SIG, I'm not attached to it. We can scope it any way you like. Anyway, on the top of this figure, there is this binding mechanisms. And what we found was that basically 4 different mechanisms which are used in different implementations or which are possible. That is the client's attestation nonce, and there is this R data field. That was what I was referring to, that we have from our SIG never given out the implementation guidance to folks that, hey, this is the value you should really be using in our data. And people are doing like random things which are really ad hoc. Like some people are using even Meta, even after their security review, still they are using the the TLS nonce, which is really wrong because they have no freshness of the evidence. So this is why I'm saying that this guidance is really necessary, that we as SIG, let's say, maybe not specifically attached to AI and all that, but this is a really important thing that we need to give out to implementers, that what they should actually put in these kind of fields, because everything else is provided by the hardware. So the guarantees are coming from here. What they have to do is to define what goes in that the attested TLS protocol. Let's say what we will design at the IETF, for example, and then what binding mechanisms they put into it in their implementations. I think that's, in that sense, this is valuable guidance for them. That so we explored what they do, like all the 4 options that we currently have, and then some combinations which make sense to us. For example, this client nonce combined with public key, and I take server as a tester. That's why I'm using server's public key. And similarly, client's attestation nonce combined with server's public key. And the kind of feedback I would like to have is that, is anyone aware of any other binding material or combination that we should look into or analyze for the various security properties? And looking at the clock, I think I will quickly jump. Then please give feedback on the list. I will try to wrap up very quickly. This was a slide I was referring, has a lot of details, but I will uh, just a reminder, because I try to make it more clear. The discussion already concluded on the list. So the thing is that client basically needs to care about this secret at the end of attestation, what it will give it over to the server as a tester. So it cares about this secret, and because of this, it's the application traffic secret, this key which is derived from application level, that it needs to care about. And this one, even if I remove all of these encryptions, which are for the handshake messages, it really doesn't matter. All the security properties remain the same, even if these encryptions from 1C to 2D are completely removed. So that's the simple argument that we discussed. And the 2 relay attacks I have are abstracted here, that the adversary can get a nonce, forward it over to some genuine AI agent, get a genuine evidence, get it back, and then relay it over back to it. And then the channel that will be established will be with this adversary rather than the genuine AI agent if the binding is weak. And more specifically, the second attack is that if it has access to this private key, which the genuine AI agent has, and what it can do is to establish a connection with the genuine AI agent, and then use that key to sign for certificate verify message. And if the binding is weak, it doesn't need to have anything else at all. So everything it requires is just this key. And the property that we want is that even if this key is leaked, the adversary actually should not be able to build the connection with this, and this should somehow not be possible. That's the security property, such that if the AI agent now forwards it to some other AI agent, it can detect that this key doesn't belong to that specific agent. So that's the main thing that we are currently looking into. And as I said, there are a number of implementation issues like that we discovered. For example, Meta's AI, I already mentioned, they use TLS nonces and no attestation nonce, so they have evidence freshness problem. And people are using various things, as I mentioned, like previously, Edgeless System and Cocos AI were using or abusing, so to say, like SNI field, which is for host name. Edgeless System has now shifted to ALPN, which is still wrong because that's for protocol names. That's not meant to be for attestation nonce. And CCC Proof of Concept, which is an adopted project, has had no update for 3 years. I'm not sure what's the plan there. And one question that I wanted to ask was, is there any
When you
other
say CCC proof of concept, what do you mean by that?
So there's an adopted project in the SIG, attestation SIG, where we had this CCC I should have written SIG maybe, attested TLS proof of concept. And the plan there was to build a intra-handshake attestation implementation. And currently,
Okay, but nothing happened. Okay. So,
yeah,
Marcus, sorry, you had your hand up. I'll see it to you.
Yeah, thanks. I just wanted to get the clarification why the TLS nonce does not provide evidence freshness if it's intra-handshake. So I would understand the argument if it's post-handshake and you can reattest. But if it's only in the beginning or in the handshake, why is using the TLS nonce a problem?
so that is a problem. So that is basically a rat's philosophy, so to say, that evidence freshness is not the same as the protocol freshness. And that's the high level argument. Of course, I can follow up on the list with more details on this. And that is to say, when you have TLS nonce being used instead of the attestation nonce, or TLS nonce as attestation nonce, that doesn't give you evidence freshness, that only gives you protocol freshness. So that comes mostly from the RATS philosophy. So I will point you to the documents that we have in RATS,
So,
which describe more detail.
so we only have a couple of minutes. If we could come to agreement on some of these things, so go back a slide, I think.
This
No,
one?
no, forward one. No,
This one?
back one. Yeah, that one. So, for instance, if we as a group were able to say, we think that you should do these things, and this is the official advice of the CCC about how you should use, for instance, SNI, right? I think that would be a very useful thing to put out to the community. Yes, there's other things we could do beyond that, but just that level of granularity, I think, is an appropriate thing for this, for this group to be doing. Do other people agree?
Well, if you want to hear my 2 cents, I don't think it's helpful to point out other people's abuse of
No,
existing
you don't do it
properties.
that way. You
If
don't do it
there's
that way. You say you assert the correct way of doing things is
yeah.
this.
And if there's a correct way, then this is perfect. Yes. Otherwise, like just saying don't use this does not help.
No, you explain why it should be done and what the reasons are for doing it in a particular way. But I
Just
think
to
these are small, slightly more tractable things that we could be doing fairly quickly if we could come to agreement on some of this stuff.
So just to clarify, Marcus, so the reason of this research is not to say that, hey, all of the folks are abusing it. So we did extensive research, and that was the outcome of this. And that's the reason of coming here, is to say that there is a need for that. And it's not finger pointing that, let's say, Agilus is doing this and this one is doing this and all that. The reason I'm pitching it over to SIG is that there is a requirement for the community that folks actually don't know what to put in this field. And the neither the, let's say, the TE developers nor the cloud providers provide you any guidance on how to do that correctly. And even speaking from IETF perspective, let's say, as one of the authors, so that will also be, of course, that will be maybe two implementations developed, but I think it will remain vague, like, okay, whatever your use case is, use accordingly. The specification, I believe, I'm not sure, I think it will never say, hey, actually, you should put exactly this thing so that it is secure. I think that will be kind of left over to some specific use cases. And we have for confidential computing a very specific use case. So I believe it will be, my point here is that neither the ITF nor the cloud providers nor let's say the TE developers and all that, no one is providing this guidance, and SIG is the right place that should be providing this kind of guidance. And this is the work that we need to kind of do, or should be done at least. That's my idea of proposing this project.
Yeah, fully agreed. Thanks. And in the context of pointing out that nobody knows what to do and that there needs to be central guidance, I am fully with you. Yes.
Okay, cool.
Cool. I think we're
Any other
probably
thoughts?
done.
Yeah,
Okay.
we're a minute over time today, so it sounds like a good breaking point. Thank you, Osama. Thank you, Stephen, who's no longer here, for presenting today. And I'll coordinate with the chairs offline for our meeting in a couple weeks.
Cool.
And thanks,
Thanks a
John,
lot.
for being involved from your side and explaining what the situation is. It's helpful.
Yeah, thank you, John.
you.
No problem.
Thanks, folks. Bye.
See you.
Thanks.
Bye.
Bye.